We'll quickly start with the recap of last two sessions that we have learned so far. In the chapter one, we talked about the app service and the app service plans, where we learned like how can we create the app service and the app service plans, as well as the scaling features from the chapter two, and how can we deploy the app service using different mechanisms like using FTP or from Visual Studio, and the slot settings that we have, the main feature of the app service. So where we can use where we which we can use to deploy using a zero downtime. So that was the major thing from chapter one, and from the chapter two where we talked about uh, scaling up, scaling down, basically scaling vertically and horizontally, and the like what would be the difference between those two terms, and what all the metrics that are available to us, the different sort of metrics available with the app service and the app service plan, where we can see the CPU, memory, number of incoming requests at the app service. So all those things we have covered in chapter one and two. So in this chapter, we are more majorly focusing on the endurance of the app service. Basically, what it means is how can you strengthen your app service based on the reliability and the availability of your app service. So let's see what will be the things available in this chapter. So we'll be talking about the health check feature of our app service. So you people might have heard about the health check with the APIs and other apps, other type of websites where we will be checking the major components available to us and how it is configured on app service. We'll be talking in this chapter. Then we have one major feature for the availability and to improve the resiliency of the app service. We have auto healing with us, and there is one more feature called proactive CP monitoring. In case of, let's say, we want to monitor our CPU if it is running beyond the threshold limit, so we can take the necessary action on top of that. And at the last, we will be talking about the crash monitoring. So in production websites, we generally see like our app website goes down with some exceptions, or certain incidents that happens. So we can monitor those things and gets do the analysis on top of that and get rid of in future for from those exceptions. So that we will be talking about in this section. So let's quickly start with the health check. So what we will be talking about, the how health check feature is configured in such a way that it will be routing the traffic to the healthy instances only. So what app service does is, we in the app service there is a health check we configure, and app service performs the health check on all the instances of the app service, so that it checks that path if that is available. So the traffic would be routed to the healthy instance only, that are returning the response without any exceptions. So health checks automatically removes the fault instance from the rotation, thus improving the availability of our app service. So basically what happens is, whenever a health check app service performs the health check, if if the instance is not responding well, so it waits for a certain period of time, and it moves out that particular instance out of the rotation, so that traffic will not be traffic will not be routed to the unhealthy instance, where the client who is requesting the website will not see the 500 or some sort of unwanted behavior of our application. So that as a general practice, we should check all the critical components of our application via this health check route. So in general, our application depends on the database, sometimes on the Redis for the distributed caching, and sometimes on the event queues. All those things are the part of our application. So we should check all the most critical parts of our application using that health check route. So as you can see in this diagram, so how does it works is, So let's say we have three instances running of our application on the Azure App Service. So let's say if one instance goes down, so the App Service automatically rolls out that particular unhealthy instance out of the rotation from the load balancer. The traffic would be rerouted to the remaining instances, the remaining healthy instances actually. So the most important thing before configuring this health check is app service plan must be scaled out to two or more instances to so that this feature can be used. Of the feature basically that kicks out the unhealthy instance. Otherwise, if you would be having only one instance, so this feature will work. This will you will be able to enable the feature, but it will not like move out the faulty instance from the rotation. So that is an important tip to note. So let's talk about how does this health check behaves. So as we all know, as I've already talked about, app service will ping the specified health check path on all the instances. All the instances means like it will be checking continuously all the running instances of your app service. So health check path must respond with a status code between 200 and 299 to be healthy. So if the status of your health check path is not in this range, so it will be considered as unhealthy. So if the instance does not respond within 10 minutes, in the 10 minutes, it app service pings the instances 5 times, and that if the response is if we don't get the response within the above mentioned range, the instance will be considered as unhealthy and moved out of the rotation. So that's how health check feature helps us to maintain the resiliency of our app service. So if an instance remains unhealthy for 1 hour, so what it does is it automatically uh, it automatically replaced with a new instance. So the underlying W3W2 process would be restarted and it will be added back to the rotation if that instance is responding well after 1 hour. So in case of scaling up or scaling out, this feature helps us in maintaining the once we scale up or scale out. So our app service will take some time to warm up. So during that period of time, if our health check will prevent that instance to be added to the load balancer. So that's also additional functionality that health check provides to us. So let's quickly see how we can configure the health check on our app services. So you can see that this is our app service that we have created beforehand. There is a monitoring section in this app service where you can check where you can get the health check option. So you can see our website is running on a single instance. So this information note is already mentioned over here. Your site has a single instance which will not be removed if it becomes unhealthy. So that we already talked about. So it is by default disabled. Once we enable it, it asks for two things. One is the path that we want to check for like the path of our application that this app service will be pinging continuously to check the health of your app service. And there is a new feature added by the Microsoft. They have given you the flexibility of configuring the duration by which the faulty instance would be added to your would be available to the load balancer. So we can configure it starting from 1 minute, 2 minute to the 10 minutes of the duration. So by default it's 10 minutes. We'll keep it like this only. The path that I'll be checking is the slash path. So main path of our application would be if that would be available, that would be responding with the range of 200 to 299. So the instance would be considered as healthy. So I'll save this. So one more important point is so this feature is basically adding a setting in the configuration section. So this will need a restart. So once you change any of these things, so it will restart your app service. So this will be restarting my app service. Now this is configured. That's it. So now our app service will be the instances would be checked for the path slash. Once the path is responding with the 200 response, the instance would remain healthy. So from the metrics also, as we talked about in the chapter 2, so there is a metrics also available to us which we can see for the health of our app service in the past. So I have enabled this just now, so that's why it is not showing anything. Otherwise, you can see the health check status of your app service in the past through these metrics. So that's about the health check. So we'll quickly move ahead with the auto healing feature of the app service. So basically, what does auto heal does is it provides us an easy way to take an action when our app service is having an unexpected behavior. So unexpected behavior could be anything in between these things. So if let's say if my app service is having a high load, request duration is high. So if some pages, if the some of the pages of our app service or the every request is degraded, so we can configure certain rules on top of this to mitigate this situation. If let's say our memory of your app service is reaching beyond the threshold limit, so you can use this feature. Let's say if your request count is high, then incoming request on your app service is high, and you are not able to serve the load. So in that case also, this feature help you to mitigate the situation. And the last option is the status codes. Let's say if your app service instance is returning not apart from the 200, it is returning the 400 or 500 continuously. So you can configure certain actions on top of that, or on top of those status codes as well. So what sort of action we can take on in these situations? So either whether we can recycle the process, and we can log an event so that we can notify the administrator that we are having this kind any of these kind of situations, and they can take the necessary action on top of that. Otherwise, we can create any custom action. We can configure any batch script or shell script that we want to run on in any of these situations, so we can do that as well. So that's the auto healing feature. So the most important tip for this feature is basically this feature is only available with the Windows right now. So if you go with the container based or the Linux based app service, so this feature will not be available right now, but in future it might be. So that's a important thing to be noted over here. So as we've talked, there are the various triggers available to us: is slow request, memory limits, request count, and the status codes. And the necessary action can be restarting the process, logging an event, or starting another executable. So that could be the actions that we can take. So let's quickly see how can we configure the auto healing. So we have one section called diagnose and solve problem that is dedicated to the resiliency and the availability part of our app service. So there we have multiple features called availability and performance, diagnostics tools, configuration management. So we can do many things in this section. So majorly we will be focusing in this session is diagnostics tools. So there we will have all these options. So quickly, you can see there are multiple options. So we'll be talking about one by one. So starting from this auto heal. So as I told you, that auto heal feature is by default disabled, and it is recommended for the production ready application. You should turn this on, though it is not the eventual fix of the problem, but you can mitigate the current situation. You can mitigate from the current situation, like uh, that you the unexpected situation that you are seeing right now. So I'll be showcasing the memory limit. I'll be creating a rule for memory limits if memory reaches beyond, let's say, 90%. So currently I am a standard plan, so that is on 1.75 GB. I'll quickly do a calculator. So 1.75 GB to multiply by, let's say, 80%. So it's somewhere around 1.4 GB of the RAM, which is equivalent to 1500 of 1500 MB. So I'll be configuring it as 1500 MB. So you can see private byte, it shows you the message. The private byte should be in between 102400 MB to the 13 GB, because we have the only, we till now maximum we can have the 13 GB of the RAM. So it shows that message to us. So we have to give the value in the KBs only. So 1024. I'll be configured for 10 GB. Sorry, 1 GB. Okay, so you can see the 1000 MB. If my app service reaches beyond the 1000 MB, what actions I want to take is I'll be recycling the process, the underlying WP process. I'll be recycling that. And this there is one more feature given to us, override when action execute is. So when, let's say, our app service is starting, and at that point in time our app takes a lot of memory, so we can configure this value so that this feature will be executed after certain period of time. So we can modify according to the startup time of our application. So I'll not be configuring this right now. So if you see, it shows that review and save your settings. So currently there is no rule configured, and the new settings would be that if the process consumes more than 1000 MB private bytes of the memory, so what we will be doing, we will be recycling the process. So the action is already written over there. So they're showing some warnings. So will be reading it later on. So once I click on save, so it will be saved for the future. So this feature is saved. You can see the it changed the value of the current setting, and this it shows process would be recycled if our memory would be 1000. The process consumes more than 1000 MB of the memory. So that's how you can mitigate the situations in the production. So let's say if we have 13 GB of the RAM currently in hand in the production ready app service, so you can configure it. Let's say if it reaches beyond the 90% of the limit, so you can trigger this action and it will recycle the process, underlying process. So one more important point is uh, it it is doing it will do the auto heal instance by instance, not for the complete app service in one go. So that's also an important point to note. So that's about the auto healing feature. We can explore other things as well, and if you want. So request count you can configure. Request duration. If, let's say, if you have any certain limit, like let's say if your limit is, let's say, 3 seconds is the upper hand of your response time of your application, you can configure accordingly. So that's how you can configure the auto heal and prevent your app services from the unexpected behavior. So quickly move ahead with the proactive CP monitoring. So basically what happens is, whenever we have a high load or any situation where our CPU is spiking, so this particular feature helps us in preventing those situations. So proactive CPU monitoring provides an easy way to take an action when our app service or any of the child process for our app is consuming high CPU resources. So as its name suggests, so there are triggers given to us. So there we can define the threshold of CPUs from ranging from 75% to the 95%, that which we can take the necessary actions. And this feature also helps in mitigating the issue by killing the process consuming the high CPU. So the same thing that we did with the auto healing, similar thing can be done with this proactive CPU healing, proactive CPU monitoring, where based on the threshold you can restart a process. Based on that, you can restart your process. Sorry. So to configure this, we have like 7 steps that we will be taking to configure this option. So we need to set the CPU threshold, and the threshold seconds could be like uh, for how many seconds we will be waiting for this process, for this option to kill the underlying process. And the monitoring frequency is uh, the polling period. So till what, in which frequency we will be polling the this polling the metric, and what action we want to take. So we will be configuring the actions, and the maximum actions we can take on this. So that we will be configuring with these options, and the maximum duration for which this feature is enabled. So Azure says that this feature is not permanent, because this is a heavy task for the app service to be continuously running. So they suggested to configure it whenever you see any such kind of situation. So they have you can enable this option starting from 14 days to the 30 days for the max. You can not keep it like active for the complete uh, permanently. And this with this option you can also monitor the web job processes that we have talked about earlier as well. So we'll quickly see the examples of this proactive CP monitoring. In the similar section on below the auto heal, we have this proactive CP monitoring. So to configure this proactive CP monitoring, as you will be taking the memory dumps and other things as well, so you have to have a storage account with you where you can save the memory dumps and the network traces that this process will be capturing. So once we enable this, similar options that we talked about. So we will be setting the CPU threshold starting from 75% to, let's say, I'll configure it as 90% of the CPU. And the threshold setting says for the row trigger, CPU should exceed 90% of this many seconds. So if the CPU CPU ranges between 90 more than 90% for more than 30 second or 60 second, I'll configure it as for 60 second. Then what actions we will be taking is collect and kill. So what is the meaning of this collect and kill? So collect and kill is basically it will collect the memory dump for you. So it is written over here that a memory dump is collected, and the for the process that is consuming the high CPU, and it will kill that particular instance and respawn a new one. So that is the action that I will be configuring. There are multiple options, whether I can kill only, collect, or only collect the memory dump. And there is one more option called collect, kill, and analyze. So then and there it will be analyzing the memory dump. So I will go with the default options. The maximum number of actions that we will be taking is two. Only two maximum number of two dumps would be taken once we enable this feature. And the duration starting from 1 hour, we can configure it for maximum of, let's say, 30 days only. So as I said, this feature is not permanent, and we don't want to monitor the web job processes. So as part of this configuration, so you can read this rule over here as well. So when the site process or any child process of the site's process takes 90% of the CPU for more than 60 seconds, collect a memory dump and kill the process so that we can mitigate this situation. So evaluate the CPU every 15 seconds. So this will be polling the CPU metrics in every 15 seconds, and it will collect a maximum of two memory dumps. So once I will save, so this will enable this CPU monitoring for me. So once I enable, you can see that in the observe section, it will show you the current instance running and what is the CPU percentage is there on top of the same instance. So it will be showing you for all the instances. So currently we have only one instance, so it will show for that. So in the analyze section, we can see that what rule we have configured and if there is any dumps collected so far or not. That's about proactive CP monitoring. So let's quickly go ahead. It will once it will show you, I'll show you back. Once it populates uh, the instance. So let's quickly go ahead with the application crash. So what would let's say if our application is crashing, so what we will be doing is it unexpectedly it is crashing. So what we will be doing will enable this crash monitoring. It collects the memory dumps and calls back information at the time of crash to identify the root cause. So how does it works is the agent attached a debugger when process starts and the process crashes with an unhandled exception, the debugger captures a memory dump. So that's how this application crash works. So basically we are running out of time. So I'll be quickly showcasing you the application crash. So how can we configure this on the portal? So this is the crash monitoring. Simply, what you can do is you can configure the storage account and define the start time of this collection and the stop time and the maximum number of dumps that we will be taking. So this is also not the permanent thing. So uh, it's basically useful whenever you see such kind of behavior and you are able to replicate those things. So you can configure this option and have the memory dumps and analyze it further in for your future references. You can to mitigate this issue. So there are another diagnostics tools available to us. So one is the connection strings. So let's say if you want to check your connection strings in your application and that you have configured for the SQL. So there is a section called can check your connection strings. There you can check what all connection strings you have and are you able to reach to those connection strings or not. So this will show you. This section will show you that option. And then we have a memory dump. Let's say if you want to take a separate memory dump apart from all these options, you want to take a memory dump. So you can do it from here as well. You can configure it accordingly. It will show you the list of instances that are available into your application, and you can collect the memory dump for those instances for you. And those will be stored on the block storage. Quickly we'll talk about the network trace. Let's say if you're seeing any network contingency or anything like you're not able to connect to any instance or any other third-party service. So if you want to collect any network trace, you can have this option from here. And for the quick 60-second you can collect the network trace and analyze it further. So I think we can quickly wrap this up and I'll hand it over to Ravi for the last section of our uh, this demo.